Hello everyone. Today I will discuss principles of hydrostatics. Pressure. Pressure is the force per unit area exerted by a liquid or gas on a body or surface with a force acting at right angles to the surface uniformly in all direction or at any point of the area. So ang formula ng pressure ay P is equal to force F over area or A. The term pressure is often used as abbreviated expression of intensity of pressure. It is usually measured in Newton per meter squared or Pascal, in honor of Blaise Pascal and pound per feet squared. So in class, it's very important na mapag-aralan or matutunan din natin ang pressure. Why? Kasi tayo sa discipline natin ng mga engineers is pwede tayo mag-work sa mga facilities like water district or nawasa, Manila Waters or kung saan pa na deal with water kung saan ay may encounter din natin yung pressures. It is very important that we know ideas about and knowledge about pressure. Okay, Pascal's law. It is developed by French mathematician Blaise Pascal. States that the pressure on a liquid is equal in all directions and in all parts of the container. Consider the infinite Consider the infinitesimally small wedge-shaped volume. So ayan, BCD shown in the figure, in which the side BC is vertical, CD is horizontal, and BD makes any angle theta with the horizontal. So let A1, A2, and A3, and P1, P2, and P3 represented the areas and the pressures respectively. So yan class, based on the figures, ayan, consider natin yan. Since the wedge is at rest, the principles of equilibrium may be applied to it. So yan, from the definition of pressure, it is known that the pressures are perpendicular to the surface faces of the edge. Choosing the coordinates axis, summation of x is equal to 0 and summation of y is equal to 0. So using class yung equation F is equal to PA, derive ito class dun sa equation dun sa formula ng pressure na F over A. So, ang value class ng F is equal to the pressure multiplied by the area. So, and based on the figure, P1, A1 minus P3, A3 sine theta is equal to 0. So, ito class, ito yung pressure along doon sa X. So, ayan, we have the pressure 1. We have the force 1, which is equivalent to pressure 1 multiplied by area 1 minus the pressure 3 multiplied by A3 sine theta is equal to 0. So, summation of y naman class, summation of forces along y. Assume din natin na equal to 0. So, yun naman ay P2, based on the figure pa rin, P2 A2 minus P3 A3 cosine theta. So, ayan. Based on the figure class, we can analyze that A3 sine theta is equal to A1 and A3 cosine theta is equal naman to A2. So, therefore, yung value ng P1 is equal to P2 is equal din sa P3. So naman class, in the figure shown, as liquid flows into the large container at the bottom, pressure pushes the liquid equally up into the tubes above the container. The liquid rises to the same level in all of the tubes, regardless of the shape or angle of the tube. So dito naman class, kahit mag-iba-iba pa yung shape nung tube sa paglalagyan natin, yung level ng water niya is same lang. Ano? So yun class yung property din ng liquid. Kahit anong shape pa siya, basta nasa isang container siya, so magkakaroon siya ng same level. So this law of fluid mechanics is observable in many everyday situations. For example, the pressure exerted by the water at the bottom of the pond will be the same as the pressure exerted by the water at the bottom of a much narrower pipe provided that the depth remains constant. So ito class, ang commonly na-experience natin siya yun na lang, example dito, halimbawa sa bottom ng pond. Yung pressure dun sa bottom ng pond is same kapag halimbawa naglagay ka ng pipe, kahit anong size pa ng pipe yan, as long as yung pinakadulo ng pipe na yun is level doon sa bottom ng pond na tinutukot na inaalam mo yung pressure. So meaning, ang pressure is kahit gaano pa siya kaliit na pipe or kahit in compare doon sa wide na pond itself, ang pressure nun is same as long as same sila ng level na. Ito naman sa free surface of a liquid. Strictly speaking, liquid having a free surface is one whose surface there is absolutely no pressure. It will be shown later. However, that there is always some pressure on the surface of every liquid called atmospheric pressure. So the free surface of a liquid is considered to be surface that is not in contact with the cover of the containing vessel. So how about the free surface of a liquid? Dito naman class, ang tinutukoy naman nito is ang tinutukoy naman ng free surface of a liquid dito based on the picture is yung surface kung saan wala na yung tubig. So dito class sa picture na ito, meron diyang isda and then may bubbles. So ang free surface of a liquid niyan is yung ibabaw nung tubig. So yung ibabaw niyang water na yan. So naandyan ang free surface of a liquid. So yan. Meron tayo dito class tatlo. The gauge, atmospheric, and absolute pressure. So ito yung mga dapat nating malaman. Yung pagkakaiba-iba nito at kung ano ang tinutukoy nito. Gauge or relative pressure. Gauge pressures are pressure above or below the atmospheric pressure as the base and can be measured by pressure gauges or manometer. For, for small pressure differences, a YouTube manometer is used. So yun yung ginagamit sa pag-alam ng gauge pressure. The term pressure that this course wants us to calculate at any point of a container pertains to gauge pressure. So yun yung class na madalas ay i-calculate natin dito sa subject na ito. The concept of zero pressure on free liquid surface means that there's no gauge pressure exerted on that surface. It is subjected to atmospheric pressure only. So ito class, ang zero pressure is doon na siya sa ibabaw. Yung sa pre-liquid surface, yung wala ng liquid. So kapag halimbawa dito meron kayong reference na iba't ibang level ng tubig, aalamin nyo yung pressure per that level of water. Yung pinakaibabaw nun is yun yung pre-liquid surface, which is the pre-liquid surface I mean. So dun yung no gauge pressure. Subjected lang siya sa atmospheric pressure only. Atmospheric pressure. All gases possess mass and consequently have weight. The atmosphere, being a fluid composed of a mixture of gases, exerts a pressure on every surface with which it comes in contact. And intensity of atmospheric pressure decreases with altitude. So yun class. So ito ay composed ng mixture of gases and nag-exert lang siya ng pressure doon sa surface kung saan siya in contact. So yun, tandaan nyo class na intensity of atmospheric pressure decreases with altitude. Mas lalo maintindihan natin ito class kapag nagsosolve na tayo ng problems. Ayun. Again, part pa rin ng atmospheric pressure. Vacuum. When you say vacuum, absolute zero is a space that has all matter removed from it and can also be described as a region of space where pressure is less than the normal atmospheric pressure, 760 mm or 29.9 inch of mercury. Negative gauge indicate the amount of vacuum. So dito naman class, pag sinabi nating vacuum, absolute zero siya. So dito, tingnan natin itong mercury barometer. So ito, a mercury barometer is an accurate and relatively simple way to measure changes in atmospheric pressure. At sea level, the weight of the atmosphere forces mercury 760 mm, 29.9 inch up a calibrated glass tube. Higher elevations yield lower readings because the atmosphere is less dense there and thinner air exerts less pressure on the mercury. So dito class ito. So ang illustration na yun is merong tubig, naglagay ng tubig sa doon sa may sea level, ano? And then naglagay ng mercury tapos yung portion doon class sa ibabaw na parang space is yun yung tinatawag na vacuum. So ang nangyari diyan class is you have the container and then at sea level nilagay mo yun and then you have the mercury tube o yung instrument and then pag check ng pressure yung gauge is umabot siya ng 760 mm. That is why andyan class yung normal atmospheric pressure niya is 760 mm or 29.9 inches of mercury. So yun class yung naging lumabas. So yun. And then yung ibabaw niya, after that 760 mm, yun naman yung tinutukoy na nun is yung vacuum or absolute zero. So ganyan lang class yung ginawa na way para ma-check or ma-determine yung ma-check or ma-determine yung changes in atmospheric pressure. So under normal conditions at sea level, ayan class, atmospheric pressure is equal to 2,166 pound per feet squared or equivalent ito sa 17.7 psi and then equivalent na siya sa 29.9 inches of mercury. So ito yung class yung reading of mercury in the barometer. So yun yung class yung naging reading. Or 760 naman siya in terms of mm. And then in terms of kPa naman, 101.325 kPa. So ito class, ito yung mga values na dapat nating ma-memorize kasi gagamitin yan sa pag-solve ng mga problems about pressure. Next, absolute pressure. Absolute pressure, pressure above absolute zero. So absolute pressure is the lowest possible pressure attainable. Absolute pressure can never be negative, always equal to gauge pressure but always equal to gauge pressure plus atmospheric pressure. So yan class, ang absolute pressure naman ay equivalent lang siya dun sa gauge pressure plus atmospheric pressure. Intensity or pressure at any point. So ito naman class, consider 2 points whose differences of elevation is h to lie in the ends of an elementary prism with area A and length L. Since at rest, consider principles of equilibrium. So ito class, meron tayo ditong figure. We have the pre-liquid surface, which is the surface refers to the liquid surface subject to zero gauge or with atmospheric pressure only. And then, meron tayong nilagay na tube. Tube yan class na nakaslant. So, meron yung dalawang force, the F1 and then the F2, and then the length, and then the weight. So, ayan class. So, P1 class, so meron din siyang pressure ano. So yung P1 and P2 are gauge pressures. And then the area naman is same lang doon sa buong tube. So ayan. So yung illustration, ayan yung difference niya dun sa difference ng elevation niya nung dun sa F1 and F2 ay H is equal to L sine theta. So yan class. Based on the figure class, we all know that weight is equal to unit weight multiplied by volume. So dyan, ang volume dyan is yung value ng area multiplied by the length. And then by summation of forces along Y, assume natin which is equal to 0. So makukuha natin ay F2 minus F1 kasi magkaiba sila ng direction. So ang positive natin is going up and then ang negative naman natin is going down. Equal siya sa W sine theta. Ano nakukuha? Since ang W class is equivalent to the unit weight multiplied by area and then the length. So ang equation natin ay F2 minus F1 is equal to unit weight multiplied by A L sine theta. So ayan, compute na natin. So we all know that force is equal to pressure multiplied by area. So ayan, so P2A minus P1A is equal to the unit weight AL sine theta. And then, based on the figure class, ang value ng H ay equal siya sa L sine theta. So palitan natin. Ano? So yan, ang magka-come up tayo sa equation na pressure 2 minus pressure 1 is equal to the unit weight multiplied by height. So ayan, so itong equation ito class, magagamit din natin ito sa mga susunod na topics natin. Ano?